Hey everyone, this is a video reviewing the exponent rules from section 1.3 in a little more detail. All right, so you have here this chart of all the rules, which can also be found in your textbook in section 1.3 right before the homework problems. So we have the product rule that says if they have like bases, if powers have like bases, you can add the exponents, keep the base. Now that is coming from, let's look at where that's coming from. Let's say 2 to the third times 2 to the fourth, okay? Technically, that's not a 2. That's a 2 to the third, which is really 8. And technically, that's not a 2. That's a 2 to the fourth. Now, if we open this up to what it really means, it's 2 times 2 times 2. And this really means 2 times 2 times 2 times 2. And it's multiplying. So really what we have here is 1, 2, 3, 4, 5, 6, 7 2's. So what's really going on is that this is the same as 2 to the 7th. So instead of opening it up every single time, we kind of come up with a rule that says, wow, it's exactly the same as keeping the base and adding the exponents. So that's the same as 2 to the 7th power, which makes it really nice for when we have problems like 2 to the 12th times 2 to the 13th, right? We don't want to write 12 2's and 13 2's when we know that it's just going to be 2 to the 25th power. So there's 12 2's multiplying here, 13 2's multiplying here, so it's 2 to the 25th power. Now for the quotient rule, 6 to the 7th over 6 to the 4th, okay? I know that it says here that it's subtraction, which it is. A to the m over a to the n is a to the m minus n. But where is that coming from? That's coming from, there's 7 6's on the top. 1, 2, 3, 4, 5, 6, 7, multiplying. 4 6's on the bottom, multiplying. And we're going to reduce. And that leaves us, did I reduce correctly? Oh, maybe I didn't put 7 6's. Let's see, 1, 2, 3, 4, 5, 6. There we go, 7. Okay, 7 6's on the top multiplying, because that's what 6 to the 7th means. 4 6's on the bottom multiplying. And if we reduce, we end up with 6 to the 3rd power. And then you're like, oh, it's exactly the same thing as keeping the base and subtracting the exponents top minus bottom. Sometimes it's easier to just visualize them being reduced. You don't need to write 7 6's and 4 6's out, but you can see that this one's heavier, so it's top heavier. So 4 of these are going to go away, leaving 4 of these going away, leaving 3 left over. Then we have our power rules, and let's get this out of the way here. So we're going to look at our power rules now. And in these power rules, you have any powered number raised to another power is the same as a to the m times n. So the powers end up multiplying. And we talked a little bit in class about why that is true, okay? And 2 to the 3rd raised to the 2nd power, if we do it the long way, that's 2 to the 3rd times itself. And we see that that's 2 to the 6th power because 1, 2, 3, 4, 5, 6 2's multiplying to each other, which makes 2 to the 6th power. So you kind of make the connection that this number and these two, oh look, I do have 2 of them. This number and these two mean the same thing. Okay, if 2 values are multiplying, if there's a product inside the parentheses and there's an exponent outside, that exponent belongs to both of them. Same for if there's a fraction inside the parentheses, that exponent belongs to both of them. And if one of these guys already had an exponent, like let's say we had something like I don't know, 2x squared, and that's being raised to the 4th power, then we've got 2 raised to the 4th power, and we've got x raised to the 8th power, because this exponent is meeting this exponent, so we're using exponent to exponent here, power to power, okay, because that's x squared, x squared, x squared, x squared, because it's 4 of them, which is really x to the 8th power. We spent some time on negative exponents in class, so if you want to change the sign, cross the line. So since the exponent is negative in here in a numerator, remember that's invisibly over 1. That's a 1 there. Since a negative exponent is in the numerator, it'll become positive in the denominator and vice versa. And that's because negative exponents are the reciprocals of their positive counterparts. So that's why they end up flipping all over the place. So reciprocal just means flip. It doesn't always mean flipping downwards. It's just relocating it from a denominator to a numerator or from a numerator to a denominator. So a negative exponent is a reciprocal of a positive. All right, so let's take a look at some, excuse me, some example problems. So A is 2 to the negative 5th power. So I'm going to start by changing it to 1 over 2 to the 5th power. And then 2 to the 5th power is 1 over 2 times 2 times 2 times 2, 1, 2, 3, 4, 5. And I believe that is 1 over 32. In question B, which is not there, so let's look at question C. We've got 1 over, for question C, 1 over 3 to the negative 4th. That's the same as 3 to the 4th. Because 3 to the negative 4 is in the denominator. It's 1 divided by 3 to the negative 4, which is just 3 to the 4th, which is just 81. And you are expected to be able to do some of these without a calculator. So don't get too comfortable using your calculator because there's a high chance you won't be using a calculator for this test. All right, D, we've got 3 over 4 to the negative 3. So we can flip it first or apply the negative exponent first. Let's go ahead and apply the negative exponent. That's 3 to the negative 3rd over 4 to the negative 3rd, which we want to make those positive. So 4 to the 3rd over 3 to the 3rd. And we can either leave it like this or multiply this out to be 64 and multiply that out to be 27 on the denominator, sorry. Now for this problem right here, notice that the negative 3 is on the t, not on the 4. So 3 to the negative 2 is going to move down, and t to the negative 3 is going to move up. 4 is not moving. So we've got t to the 3rd over 4 multiplied by 3 squared. Again, because 3 to the negative 2 moved down, t to the negative 3 moved up. Now I'm going to clean that up. Our order of operations says exponents first. Why? Because technically he's not a 3. He's a 3 squared, so he's technically a 9. We don't want to be multiplying 4 by 3 when it's not a 3. So we're going to multiply here 4 times 9 to get t to the 3rd over 36. 4 times 9. Okay, I am going to continue to go through these problems quickly. So if we look at letter A, or problem A, it's just a power rule. So that's 10 to the 9th power. Okay, we're counting here 1, 2, 3, 4, 5, 6, 7, 8, 9 tens multiplying all together. So 10 to the 9th power. Now this problem right here where we have 8 to the 4th and 8 to the negative 2. They are like bases. They are multiplying. Excuse me. I do have this negative exponent. So it is going to be 8 to the 4 plus negative 2. Or another way to see it is it's 8 to the 4th over 8 squared in order to make that negative exponent positive. We do have a little top heavy here. So 2 of those 8s are going to completely go away. 2 of these 8s are also going to completely go away, leaving me with 2 8s on the top. So again, there's 2 8s multiplying on the bottom. 1, 2, 3, 4 multiplying on the top. Cancel, cancel. Kind of do the same thing with D. We have x to the 4th, x to the 6th over x to the 5th power. Why? Because x to the negative 5 will become x to the positive 5 if we move it to the denominator. Now in my numerator, I have x to the 10th, and then the denominator I still have x to the 5th. 5 of those x's are going to go away, leaving me with a final answer of x to the 5th power. 5 of the x's will cancel out, so those 5 will go away, and this, since it was heavier, will have 5 left over. Now if we take a look at the last problem of 4y to the 3rd times 3y to the negative 5, we can simply multiply the 4 and the 3 because they're just plain numbers, they're not power numbers. They're just 4 times 3, which is 12. And we can add these exponents because it's y to the third, y to the negative fifth, or you can say y to the third and over y to the fifth if you feel like doing it that way. Because y to the fifth is negative, since y to the negative 5 has a negative exponent, I said that wrong, there we go, since y to the negative 5 has a negative exponent, that's going to relocate to the denominator to become positive. Now you have 3 y's on the top, 5 on the bottom. So 3 of them are going to go away, leaving me with a y squared on the bottom. Since we removed 3 y's from both of them, it's all multiplying, so we could just reduce fractions. Since it's all multiplication, we could just cancel stuff out. So we're left with 12 over y squared as a final answer. All right. 12 over y squared as a final answer. I hope that one made sense. Okay, I'm going to continue to go through these. So we have 10 to the third over 10 to the sixth. So these are going to go away completely, leaving me with 1 over 10 to the third, because these will reduce down to 10 to the third for part A. Part B, or question B, we have x to the 7th. X to the 7th, over x to the third. So 3 x's can reduce. They have common factors of x to the third, leaving me to this to be x to the 4th as my final answer for B. So again, we had 3 x's in common, so the x to the third's canceled off, leaving me with x to the 4th. Now in this next problem that's blocked here, we've got 24x squared y to the 4th over 6x to the 6y. All right, so 6 and 24 can reduce because they're just regular numbers, so that reduces down by 6, making what's left, so 6 divided by 6 is 1, 24 divided by 6 is 4. Now we have x squared and x to the 6, so this one's heavier, so this is going to have the leftover. This one goes away completely. This one has 4 left over. Since there were 2 on the top, we've reduced this down by 2 x's, leaving me with x times x times x times x, or x to the 4th power. Now this has 4 y's multiplying, and this has 1 y multiplying. So 1 y can cancel off, leaving me with 3 y's on the top. Or not 3 y's, 3 y's multiplying, so y times y times y. So we've got 4 y to the third, there we go, all over 1 x to the 4th, or just x to the 4th. Okay, and then in this last problem, what I'm going to do first is I'm going to go ahead and relocate the letters with the negative exponents, or the variables with the negative exponents. So a to the negative third is going to move down, b to the negative 4th is going to move up. So we have 2b to the 4th, b to the 6th, all over 6, a to the 5th, a to the 3rd. Again, we moved b to the negative 4 up to become b to the positive 4, and we moved a to the negative 3rd down to become a to the positive 3rd. So let's start crossing stuff off. Goodbye 2, 6 reduces to 3. Oh, nothing to cross off anymore. We are just going to go ahead and multiply those. So we have b to the 4th multiplying to b to the 6th, which gives me b to the 10th power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 b's multiplying. And my denominator is going to be 3a to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8 a's multiplying, because this is a times a times a times a times a times a, and you get the picture. So let's go through these. We have 6 squared to the 3rd power, so that's 6 squared times 6 squared times 6 squared, or 6 to the 6th. We have 2 to the 3rd raised to the negative 3rd power, so that's 2 to the negative 9th, simplified to 1 over 2 to the 9th. That's a 9. All right. We have a to the negative 20th here, or 1 over a to the 20th. And in this last problem, we have x to the negative 8 over x to the negative 6, which we can flip around, x to the 6 over x to the 8, take the reciprocal to make the exponents positive. We are bottom heavy, so those 6's are going to go away, and that x to the 8th is going to reduce down to an x squared for a final answer of 1 over x squared. Okay, cruising along here. I know I'm going quick through these, but I just wanted to give you this video as an extra resource on top of the section lecture video you have from the book. So here we have 6 to the third, a to the third, since that power of 3 belongs to both factors in that product. And then you can clean up 6 to the third to be 6 times 6 times 6. I don't know what that is by memory. 36 times 6. All right, so over here we have x to the negative 9 and y to the negative third, because this negative 3 exponent is going to hit that 3 and they're going to multiply. All right, and then that one hits that 1 and they're going to multiply. 1 times negative 3 is negative 3. And we can clean this up to be 1 over x to the 9th, y to the third. This power of 4 belongs to everybody, so we've got 2 to the 4th, a to the 4th, and b to the 20th. That is b to the 5th times b to the 5th times b to the 5th times b to the 5th, or b to the 20th. And we can clean that up to be 16. We've got a lot of moving around to do here, so let's start with the numerator. We've got 3 squared, w to the 4th, y to the negative 8. Downstairs, 9 is not affected, but w is, so w to the third and y to the negative 12. So again, that 9 was not being affected by the power of 3, but the w y negative to the 4, y to the negative 4 was. Excuse me. So now what I'm going to do first is I'm going to take care of these negative exponents by flipping them around. So I'm going to rewrite the problem. Let me get some space here. I'm going to rewrite the problem to be 3 squared, w to the 4th, y to the 12th, by moving this one up, and 9, w to the 3rd, y to the 8th, by moving that one down. Now 3 squared and 9 are the same thing, so goodbye to them. I've got w to the 3rd down here, and there is a w to the 3rd in here, but with a w to the 1st left over. I've got y to the 8th on the bottom, goodbye. I do have a y to the 8th in here, so goodbye, with a y to the 4th left over. There's that subtraction that we've been talking about. Again, visualize that there are 12 y's multiplying here. There's 8 y's multiplying here, and you're crossing off 8 of them. So you're left over with 4 for a final answer of w to the 1st, y to the 4th, or just w, y to the 4th. Okay. In these problems, we are applying the exponent again, but to a quotient. So we have 4 to the 3rd over x to the 3rd. A quotient is a division problem. So remember, fractions are division, so this is a division problem. So 4 to the 3rd over x to the 3rd. With the negative 2, we can apply it, or we can switch and then apply it. I'm just going to go ahead and apply it, no big deal. 1 to the negative 2 over 3 to the negative 4. Okay, because it already had a 2. So 1 to the negative 2 over 3 to the negative 4, which we swap to be 3 to the 4th over 1 squared, also known as just 3 to the 4th. 1 squared is simply 1, and 3 to the 4th divided by 1 is just 3 to the 4th, or I think that's 81. Let's go ahead and apply this this exponent. Oh, let's apply that exponent of 3 to everybody inside this fraction. So 2 to the 3rd, x to the negative 6 over w to the 9th. I'm going to relocate that x to the negative 6 to the denominator to make it x to the positive 6. So we have 8 over w to the 9, x to the 6, final answer. Because there's nothing to cross off, simplify, reduce. Let's apply that 2 to everybody. So 4 squared x to the 6 over 2 squared y to the 6 z to the 4th. And variable wise, nothing can reduce or combine, because we don't have like bases. I could reduce here. This is 4 squared and this is 4. So if I write, I'm going to go ahead and write over it. This is actually 16 and that is 4. So we can reduce by 4, making that have a 4 left over. 4x to the 6 over y to the 6z to the 4th. And as you do these, if I'm going too fast, just pause, try it on your own, and then press play to see if you got the answer right. So in this slide, we have the order of operations. Feel free to pause and read this if you need to read it, but you also own this slide deck. And let's go ahead and do some order of operations problems. In this first one, we have 8 minus 3 times 2 minus parentheses 5 plus 6. There's a 6 back there. We're going to do the parentheses first. So 8 minus 3 times 2 minus 11. Now that we've completed the operation inside the parentheses, I can erase them or get rid of them because all the parentheses was doing was telling me to do that first. And I already did it. So next I have to multiply before I subtract. So that's because technically that's not a 3, nor is that a 2. That's a 3 times 2. So it's 8 minus 6 minus 11. Now we're going to go from left to right. 8 minus 6 is 2. And 2 minus 11 is negative 9. And last but not least, we have negative 4 squared plus, and we're going to go ahead and finish that as 15, and that is 5. Negative 4 squared plus, that's 3. And guys, it's not negative 4 times negative 4, but it is negative 4 times 4 because the square is only hitting the 4, not the negative. What would it look like if it was hitting both of them? It would look like this. So since the parentheses is not around the negative 4, which that's negative 4 multiplied by negative 4, and the parentheses is only, and the exponent is only on the 4, negative 4 squared, that is negative 16 because it's the same as negative is going to wait and you're going to do 4 times 4. That's what that's saying. The negative's like, I'll chill here. You guys, you do your thing. 4 squared, it's negative, negate 4 squared, opposite 4 squared. Okay, watch there for that, which gives me a final answer here. We've got negative 16 plus 3 to make negative 13. All right, and that's the end of your crash course for 1.3.